Welcome back. Problem 12-47. This problem is taken from chapter number 12, that is Deflection of Beam and Shaft, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the shaft is made of steel and has a diameter of 15 millimeter. Determine its maximum deflection. The bearing at A and B exert only vertical reaction on the shaft. E of this steel is 200 gigapascal. So you can see this is the shaft having at A and B bearing which exert vertical reaction force, and there is a load of 250 Newton at this point and 80 Newton at this point. The diameter of this shaft is 15 millimeter, and due to this loading the beam will deflect like this. Clear? So we have to find the maximum deflection, V max. So let's start with the solution. So first step is that if you remove this reaction support at point A, so you will be having a reaction force, let this is equal to RA, and if you remove this bearing at point B, that will exert a vertical reaction force, that is RB. So we will find this RA and RB by using equation of equilibrium. That first equation of equilibrium is that sum of all moments about point A is equal to 0, and taking the counterclockwise moment as positive. So about point A, one moment is due to this 250 Newton load and perpendicular distance is 200 millimeter, which in meter is 0.2, and this is producing clockwise, so it will be negative. The second moment will be 80 into perpendicular distance is 500 millimeter, which is equal to 0.5 meter, and it will be also negative because this is clockwise. The last moment that is produced due to this RB into perpendicular distance is 700, which is 0.700 meter, and that will produce counterclockwise movement, so it will be positive, and the sum of all moment about point A will be equal to 0. So I will write minus 250 into perpendicular distance is 0.2 meter, minus 80 into perpendicular distance is 0.5 meter, and the last one is plus RB into perpendicular distance is 0.7 meter is equal to 0. So when you calculate it, you will get RB will be equal to 128.57, and the unit will be Newton. Now we'll find RB by using RA by using another equation of equilibrium, that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So R is A is upward, so RA the second force which is 250, and that is downward, so it will be minus 250. The third force is plus 80 minus 80 because it is downward, and plus RB which is 128.57 Newton will be equal to 0. So when you calculate it, you will get RA will be equal to 201.43. 201.43 Newton. Now you have both RA and RB. So what we will do is, as we are interested to find out the maximum deflection, so we need equation of elastic curve. So we know that equation of elastic curve can be obtained by using this formula: EI into d square V over dx square is equal to moment, and this moment can be M will be obtained by using Macaulay's method. So first we will find this M, and then we'll proceed. This is your equation number A. So how you will get this M? So you can see that here we have only point loads at different value of X, while X start from this portion. So this is the case number 2, which defines the point loads, and the moment function is M is equal to P into X minus A power 1. Since this load is upward, so moment is positive, and this load acts at a distance of A from this X, R start. So we'll apply it first on RA. Since the load is upward, so moment will be equal to RA, which is 201.43 into x minus, here A is equal to 0 because this load RA acts at the start. So x minus 0 power 1. The second load is 250, that is downward, so this moment will be minus. So minus 250 into x minus, now A is 200 millimeter, which in meter is 0.2. So x minus 0.2 power 1. The third load is 80 Newton, so it will be again 80 into x minus. Total distance will be 200 millimeter plus 300 millimeter. So it will be 500 millimeter, which is equal to 0.5 meter power 1. And we will neglect this RB. Why? Because if you put it, so it will, the distance will be equal to 500 RB is 128.57 into x minus 0.7 total length. Okay, so and your x should be less than 0.7 in order to find the deflection at any point. R till 0.7, so this will be either negative or it will be equal to 0. So there is no benefit from this, so we will neglect RB. Now we will simplify it. This moment will be equal to 201.43 x minus 250 into x minus 0.2 minus 80 into x minus 0.5. So what we will do is that put value of m in equation A. So we will get E into I d square V over dx square will be equal to 201.43 x minus 250 into x minus 0.2 minus 80 into x minus 0.5. So we will integrate it. After integration, you will get EI into dV over dx will be equal to 201.43 x square divided by 2 minus 250 into x minus 0.2 power 2 divided by 2 minus 80 into x minus 0.5 power 2 divided by 2 plus C1. There will be a constant of integration. So if you simplify it, so you will get EI into dV over dx will be equal to 100.72 x square minus 125 into x minus 0.2 square minus 40 into x minus 0.5 square plus C1. Let this is your equation number 1. Now we will integrate equation number 1. Integrate equation 1. So you will get EI into d EI into V, which is displacement, will be equal to 100.72 x cube divided by 3 minus 125 into x minus 0.2 power 3 divided by 3 minus 40 into x minus 0.5 whole cube divided by 3 plus C1x plus C2. And if you further simplify it, you will get 100.72 divided by 3 will give you 33.57 x cube minus 125 divided by 3 will be equal to 41.67 into x minus 0.2 whole cube minus 40 divided by 3 will give you 13.33 into, I will write it over here, minus 13.33 into x minus 0.5 whole power 3 plus c1 x plus c2. So if I write it over here, ei into v is equal to 33.57 x cube minus 41.67 into x minus 0.2 whole cube minus 13.33 into x minus 0.5 cube plus c1x plus c2. That this is equation number 2. Now you can see that c1 and c2 are unknown constant of integration, so we will use boundary conditions to find C1 and C2. So first boundary condition is that what we will get is at x is equal to 0, we have deflection is equal to 0. So let me show you over here. Here x is equal to 0, we have deflection is equal to 0 because at point A we have a bearing support. So put in equation number 2. Put in equation 2. So ei into v will be ei into 0 will be equal to, this term will be 0, this minus 0 point, if x is equal to 0, so it will be this one, and any negative term inside Macaulay bracket will be 0. Similarly this term will be 0, and c1 into x 0 is 0, so we will left with c2. So it means that c2 is equal to 0. Now you have C2 is equal to 0, we will apply second boundary condition, and second boundary condition is that at x is equal to 0.7, we have deflection is equal to 0. So let me show you here, x is equal to 0.7 meter, where deflection is equal to 0 because there is a bearing support at point B. So put in equation number 2. Put in equation 2. So what we will get, that ei into 0 is equal to 33.57 into 0.7 cube minus 41.67 into 0.7 minus 0.2 cube minus 13.33 into 0.7 minus 0.5 power cube. Okay, and minus plus c1x. So c1 is plus, c1 is not known, so c1 into x, so x is 0.7, so 0.7 c1, and c2 is equal to 0. So what we will get is that 0, if you, this will be 0, this will be ei into 0 is 0, 37.57 into 0.7 whole cube will give you 11.515 minus the second term will give you 5.2083 minus 0.1067 plus 0.7 C1. So when you calculate it, you will get C1 will be equal to minus 8.857. Now you have this C1 and C2. So put C1 and C2 in equation number 1 to get the equation of slope. So when you put it in equation number 1, so you will get ei into v is equal to, sorry, dv over dx. Equation 1 is dv over dx is equal to 100.72 x square minus 125 into x minus 0.2 whole square minus 40 into x minus 0.5 square plus c1. C1 is minus 8.857. And if you divide ei on both sides, so you will get dv over dx will be equal to 1 over EI into 100.72 x square minus 125 into x minus 0.2 whole square minus 40 into x minus 0.5 square minus 8.857, and this is the equation of slope that we will use a little bit later. Now put C1 and C2, put C1 and C2, put C1 and C2 in equation number 2. So you will get EI into V is equal to 33.57 x cube minus 41.67 into x minus 0.2 cube minus 13.33 into x minus 0.5 cube plus C1. C1 is minus 8.857 into x, and C2 is equal to 0. So if you divide EI on both sides of the equation, so you will get V, which is displacement, is equal to 1 over EI into 33.57 x cube minus 41.67 into x minus 0.2 whole cube minus 13.33 into x minus 0.5 cube minus 8.857 x, and this is required equation of deflection, or you can say equation of elastic curve. Now in our question, it has been asked to determine the maximum deflection. So due to this load, the beam will deflect like this, clear? So we will find the maximum deflection, and you can see that the maximum deflection lies in this region, but we do not know exactly the position, and this x is greater than 0.2 meter and less than 0.5 meter. So for maximum deflection, this is the region of x. So what we will find is that, let me write it, we'll choose another color. So assume Vmax occur in the region at x is greater than 0.2 meter and less than 0.5 meter. So here you can see that the place where the maximum deflection occur, so here if you draw the tangent, this is Vmax, and if you draw the tangent, so dV slope at that point will be equal to 0. So what we will do is that put dV over dx is equal to 0, and this equation number is B, and this is your equation number C. So put dx in equation number B. So when you put 0 is equal to 1 over E into I, and that will be equal to 100.72 x square minus 125 into x minus 0.2, we will change it to parenthesis, minus 40 into x minus 0.5 square minus 8.857. So you can see x is greater than 0.2 and less than 0.5. So if it is less than 0.5, this term will be 0. So we will remove this term. So this will be only minus 8.857. Okay. So these two terms are multiply EI on both sides. So you will get 100 0.72 x square minus 125 into x minus 0.2 square minus 8.857 will be equal to 0. So simplify it, 100.72 x square minus 125 into x square plus 0.2 square minus 2 into x into 0.2 minus 8.857 will be equal to 0. So from here you will get a quadratic equation. So you can simplify it now. So I will write the last equation, which is 24.28 x square minus 50 x plus 13.857 will be equal to 0. So if you solve this quadratic equation by using calculator, you will get two roots. One is x1 is 0.330 and x2 another root will be equal to 1.729. And now you can see that the value of x is greater than 0.2 and less than 0.5. So we will discard this and we will select x will be equal to, so implies that x will be equal to 0.330 meter. So at x is equal to 0.0330, we have slope will be equal to 0. Now what we will do is that, let me copy these things and we will move towards second page. And paste it over here. So what we will do is that put x is equal to 0.330 meter in equation number C, which is about deflection. So that deflection V at x is equal to 0.330 will be equal to V max, because at this position the deflection will be maximum, and we will get 1 over E into I and 33.57 into 0.330 cube minus 41.67 into 0.330 minus 0.2 cube minus 13.33 into 0.33 minus 330 minus 0.5 whole cube minus 8.857 into 0.330. Okay, so it will be equal to 1 over EI into, this term will be equal to 0 because this will be negative term, and anything that is negative inside Macaulay bracket will be considered as 0. And when you solve all these terms, so you will get minus 1.808, and the unit will be Newton into cubic meter. This is your V max. Now you have the value of E as well, so minus 1.808, and value of E is given as 200 gigapascal and diameter is given. We will convert it into radians. So E is 200 gigapascal, so 200 into 10 raised to power 9 pascal multiply by I for circular rod is pi by 4 r power 4, and r is 0.0075 meter power 4. So when you solve this, you will get minus 0.00364 meter. Or in meter, we have maximum deflection is equal to 3.64 minus 3.64 millimeter. Or you can say that maximum deflection is 3.64 millimeter, and this deflection is downward, which is the answer of our this question. And that was all about this problem 12-47. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Also share my videos with your friends and help me in growing my channel as well. Thank you for watching.